Or that was the foxhole one.
That was the foxhole one.
This Amateur Radio Roundtable is brought to you in part by ICOM America. Well, hello, everybody out there in Internet land tonight. I'm Tom, W5KUB, your host of Amateur Radio Roundtable tonight. Hey, this is Tuesday, September 24th. Man, the months keep flying by. Anyway, I think we got some interesting things to talk about tonight. Talked to Katie. Katie was going to try to be back tonight, but she's out, I think. She may pop in here and make an appearance. Emmett from Radio Waves, he may pop in. Who knows? We've all talked about it, but if they don't make it tonight, we're going to continue. Dave just informed me that he and his wife are back in the Christmas, I forget what it is, the Christmas thing where they do the music. So they're practicing every Tuesday night now until Christmas. So we're going to probably miss Dave a little bit. He might make a few appearances, but he's not going to be with us for the next couple months very much. But anyway, hey, if you're listening out there on WBCQ, the shortwave station WBCQ up in Monticello, Maine on 5130, if you have internet, you can join us by going to w5kub.com. You can join us there, click on watch the video, join us in the chat room. You can talk directly to us. You can talk with the other people in the chat room around the world watching the show. Join our Facebook group. We've got a great Facebook group. It's called W5KUB. It's a ham radio group. It's not my personal group. It's W5KUB. We've got 8,000 ham radio operators in there now. Some pretty cool stuff goes on there. And that reminds me, from time to time, I get people sending me friend requests in Facebook. And I usually don't approve anybody as a friend. It's not that I don't like you. It's mainly, my personal Facebook group's mainly for just a few family members. So I don't approve 8,000 other hams in my personal thing. I hope you can understand that. So you can always get in touch with me on Facebook group W5KUB. I'm always there. That's where I hang out. So let's see what we got. We're just going to jump right into the show tonight with we got Rich Mosen with us, W2VU, the editor of CQ Magazine, and let me bring Rich in. Rich, how you doing tonight?
I'm doing great, and glad to be with you as always.
Well, great. You know, it's hard to believe that the end of the month comes so regularly. You know.
I know. I was, just looking at the calendar and suddenly noticed, hey, wait, this is the last Tuesday of the month.
Yeah.
So.
I mean, it's amazing how fast this thing hits us.
Yep.
Well, hey, you wanted to mention something about WWV? Talk to us about that.
Yes, WWV, the time and frequency standard station that I'm guessing that most of you are familiar with, is celebrating its 100th anniversary this year and this month. And in fact, this weekend, in the beginning of next week, they're going to have a special event station on the air. The call sign is WW0WWV. Whiskey Whiskey Zero, Whiskey Whiskey Victor, and they're going to be on the air 160 through 6 meters from this Friday the 28th through next Wednesday the 2nd, and so you can look for them. They have a website with specifics at www100.com. That's www100.com. So So you can look for them. And, of course, this weekend, we also have a contest coming up. Let me look at my official CQ calendar. And it's the CQ Worldwide RTTY DX contest.
Oh, that's cool.
And I have to keep differentiating between the DX contest and the WPX contest, but they are all great. So if you're into RTTY, then this is the time to get on the air, because our contests on RTTY as well as CW and single sideband make their own propagation, and we need all we can get right now. So if you enjoy operating RTTY and you want to do some DX, this is the weekend to do it. The CQ Worldwide RTTY DX contest weekend.
You know, I need to get back on RTTY. I was on it back in the 60s. In fact, I may have told you, I was a teletype repairman in the Air Force. I went to school for a year, so boy, I could take those machines and I could make them work, and I had my own. I had all kinds of teletype machines, but nowadays you can do it with a computer. Much better, man.
A lot less heavy, too. I remember, in my college radio club had a, I think it was a Model 19.
Yeah.
And we managed to get that going reasonably well. And we had some fun with that. But that was a long time ago.
Oh, yeah.
But we've got 2 articles on RTTY coming up, in fact, in our November issue that we're working on right now. One is one of our CQ classics. It's going to be Wayne Green's first article in CQ, which was his RTTY column, which debuted in the end of 1951, and then a much more current one about creating your own RTTY hotspot. So that's a little sneak preview of what we're working on for November. But of course, we have to get through October first.
Oh, yeah.
So, and speaking of October, is it time for me to tell you about what's coming up in October?
Yeah.
Okay, very good. It is our emergency communication special, as every October is, and we have got 9 different articles relating to emergency communications in this issue, and a whole bunch of other stuff as well. So it's a really great issue coming up. Our lead story is on Saturn, the Salvation Army Team Emergency Radio Network, and its participation in a Defense Department drill earlier this year called the Patriot North exercise, and great description of how the Saturn folks integrated their operations with the Defense Department and everyone else involved in the exercise. We actually get into a few different organizations, and that's our mini theme for this issue is organizations involved in emergency communication. Saturn is one of them. We've got another really excellent article on the amateur radio and the American Legion, and it's a story of how a ham radio club which was very active, lost its longtime home, and an American Legion post, which was struggling for membership, and they got together. The American Legion post offered the radio club space in its hall, and the 2 groups are now working closely together, and it's worked to the benefit of both of them. A lot of the hams who had served in the armed forces joined the Legion, even though they hadn't been members previously, and some of the Legionnaires are also getting interested in ham radio. So it's a very good mix, and that's what the story is about. We also have an article on the ARES Amateur Radio Emergency Service response to a wildfire in Arizona, and how the hams there helped provide backup communications in that response. And our emergency communications column, which of course is monthly, Walt Palmer, W4ALT, kind of has a mini catalog of his other articles from the past year on different things that he's focused on in each of his monthly articles. Our learning curve column, which is focused mostly on beginners, but not always, is, and certainly there's always stuff there for anybody to learn as well, is focused on MCOM Insights this month, and a review of Section 97.1 of the rules, talking about our role in emergency communications and some of the different organizations with whom we work on a regular basis in providing emergency and public service communications. Gordon West, WB6NOA, in his Gordo's Short Circuits column, talks about some new nomenclature from FEMA in its online training courses. Apparently, the incident command system courses that many of us are familiar with, like the ICS 100 or ICS 700, are no longer just 100 or 700. They now have letters after the numbers. And there's some confusion as to whether the original coursework may still be valid, or if you're going to have to repeat it to get one with a letter attached. Our Magic in the Sky columnist, Jeff Reinhardt, AA6JR, talks about CERT, Community Emergency Response Team, and how you can integrate amateur radio into that, and we have more about that coming up in November as well. Our medium and low frequency column is focused on emergency communications as well. You know, these new bands we have at 630 and 2200 meters, you don't immediately think of them as necessarily being good for MCOM, but John Langridge, KB5NJD, our columnist, talks about some portable 630 meter activity at Field Day, and an antenna, portable antenna for ground wave emergency communications. One of the things that's great about these bands is their ability to cover fairly close in with ground wave communications, as opposed to, say, NVIS, near vertical incidence skywave, for close in communications. It gives us another option for providing the, within 100 miles or so, communications on outside of the VHF and UHF bands. In our antennas column this month, Kent Britton, WA5VJB, writes about cheap Yagis for MCOM and beyond. He's been designing and building these for years. It's a Yagi antenna that for VHF and UHF with a wood beam and essentially coat hanger style wire that goes through the beam, and you can put one together for about $5, and they really perform very nicely, especially for a temporary portable situation. So that's our MCOM coverage for the month, which is all by itself. It's a whole magazine. Here's all the articles. But there's more. There's more. This is the second half of the magazine.
Oh, wow.
We've got an article on Huntsville, and I know, Tom, you were there, and I'm sure you appreciated as much as I did how many young people were there, and that was the title of this article, is the Huntsville Kid Fest. There are just so many great kids and young amateurs there that it's always great to see, and it's always encouraging, and of course being part of the Young Ham of the Year presentation. And the wonderful story included in this article about the young and new ham who won the grand prize at the prize drawing. That's just a wonderful story. I mentioned before our CQ Classics series that we started in September of as we get ready for our 75th anniversary next year. In October, our next one is from 1954, and it's titled First Experiments with Transistors. There was a competition for one of the, I think it was, who was it here? Raytheon made one of the first transistors that was affordable to hobbyists, the CK722. And they came up with it but didn't really know what to do with it, so they had a competition for hams to come up with project ideas. They were offering $10,000 in prizes back in 1953, which today would be probably over $100,000. I didn't do the calculations on it, but it's a real money. And in order, picking up on that, CQ ran a piece in 1954 on ideas for building things with transistors, and that, of course, led into our solid state column, which led into the birth of the amateur satellite program, but we'll get into that down the road. We've also got a review of the Kits and Parts Organic 5 Water QRP transceiver kit, which is really cool. And it's, I believe it is phone as well as CW. Very, very cool kit. And speaking of QRP, our QRP column this month is about the Sabre V antenna. Some of you who are regular readers may recall that we had an article several months back about the saber-tooth wire antenna by David Day, N1DAY, and Scott Route K8 SMA, our QRP columnist, has built a variation on that for field use with his QRP stuff, and that's what his article is about. Joe Eisenberg, K0NEB, in his kit building column, wrote mostly about the Central States VHF Society Conference, which was held this year in his hometown of Lincoln, Nebraska. And by the way, Joe is coming up on the 10th anniversary of his column in CQ in November.
Oh, wow.
And, yeah. The Central States Conference was also one of the main topics of our VHF Plus column, along with some more VHF de-expeditions. And that is the basics of what we've got going on. We have our other columns as well, of course. We have our annual 53rd annual CQ Worldwide DX Contest all-time records. Always good to look at and see how you stack up against the top of the top. We have our new awards columnist, Eddie DeYoung, AE7AA, has his column about CQ awards to get started. And our contesting column, propagation. Thomas Hood, NW7US, writes about NASA's fleet of solar satellites looking into coronal cavities. Thomas also always has fascinating stuff to write about the science of space weather and solar research. It's always fascinating. But that's a basic look at what we've got coming up in the October issue. Even though it is officially autumn as of today, our Summer Madness special is still going on for subscriptions. You can, if you sign up through our website or over the phone with us, you can get an extra issue for each year you sign up for, either 13 issues for 1 year, 25 issues, or 39 issues. I'm sorry, 26 issues for 2 years or 39 for 3 years. So good time to sign up or renew your subscription and get a little extra for it. And that's what we've got coming up.
Well, great. I'm going to see if I can sneak in here with you. There we go.
Okay.
Yeah. Hey, well, thanks to CQ for the contest. You guys really do open the band up, you know, and it's a lot of fun. I've worked in a lot of contests, but I've never really competed, you know, to try to win. But I do like the contest. Hey, you at the beginning of the show you mentioned the WWV. Mm-hmm. Do you have any update or any information on, you know, there was a deal at the beginning of the year that they were going to kind of turn them off. Have you heard anything about that?
Yeah, the funding was restored for that. That was, I don't know, I won't characterize it politically, yeah. But the funding was restored in the final budget, so they are funded for at least another year until somebody tries to take their money away again.
Well, that's good. You know, I guess I don't know what I'll use WWV for. Actually, I mean, you know, I've got a little MFJ little MFJ device. It's a propagation spotter. Hey, you probably know what I'm talking about. I should have got it out tonight. It's just got lights on it around the globe, and everything is time synced. And you turn your receiver on at frequency.
Right, it monitors the beacon.
Yeah,
right?
And it monitors the beacon, and the time tells you if you hear it and the light's lighting up over Asia, hey, that's coming from Asia. That's kind of pretty neat the way they do that. I don't know what they'll do if WWV goes away. We were talking earlier before the show about FT8 and some of the digital modes, how you have to have a very, very accurate clock. And, of course, that's what WWV is.
That's right.
And there are programs out there now you load on a computer to make your computer exact time. Now, that may somehow go back to WWV. I don't know. It may be that it just doesn't go back to the on-air part. I'm sure they're still going to keep a standard, even if it went off the air.
Well, most of those programs do eventually go back to WWV or WWVB, which is its 60 kilohertz transmission. That was going to be shut down along with the radio station if the budget cut went through, and that's something that all of your so-called atomic clocks that people have in their houses that are really radio receivers, which listen to WWVB and use the digital signals there to set themselves properly. Those are all tied into that, and they would have had no source of data to keep themselves updated. So I'm very glad that the funding got restored. Not only will it give you, does WWV give you the correct time, but it's a frequency standard as well. If you're aligning a radio or something like that, then you know that you've got the exact frequency set up. In fact, I think it's either the Organic 5 Water or another article that we're working on now talks about using WWV as a set point for doing your alignment of the receiver to make sure that it's set properly. And there's a lot of propagation information that's on there. There's a whole lot of other stuff. They've started also working with Mars and providing Mars information over WWV. So there's a whole lot of really useful information, both for hams and anybody using the HF bands. So it's really, in my view, a very important service.
We've got a lot of new hams that are just getting their license, and they may or may not have listened to WWV throughout all the years like we have. And one of the things I would tell them, and I guess it's still on, WWVH in Hawaii. Is that still on?
Yeah.
And if you listen, if you'll tune in WWV and listen, and you hear the clock tick and he tells you the time, if you listen right after that, you'll actually hear Hawaii, WWVH come in.
Well, it depends on the propagation.
Of
course,
and
where you're located. But I've heard that too. You can hear it in the background behind the signal coming out of Colorado.
Yeah, and, one of our people in the chat room, Glenn, our friend Glenn Popil, KW5GP. He talks about the time standard now in the, I guess, the GPS time standards. I guess satellites, and I guess really WWV is kind of antique if you really think about it, because it's been around 100 years.
100 years, yep.
Been around 100 years, man. So.
But so have we, and we're still relevant.
Yeah. So technology has moved on, and there's probably some other very highly accurate time standards out there. I want to know who the guy is. Where's the one guy that keeps the main clock, though? That's what I want to know.
Well, National Bureau of Standards, or National Institute of Standards and Technology now, has atomic clock out there in Colorado that the time signals are based on. There's another, actually I think they have two of them that they keep in sync with each other. The Naval Observatory in Washington has another one, and there are several others scattered around the world, and they all compare their times with each other, and that's why coordinated universal time is called coordinated universal time, because all of the atomic clocks around the world bring their signals together and average their readings so that they're all on track together.
Yeah, someone just mentioned, Andy just mentioned CHU. That's a Canadian time standard.
Yes.
I used to hear that. I think it seemed like it was up above 40 meters, somewhere 73.0.
73.35, I believe.
Yeah, probably somewhere in there, yeah. So.
Yeah, I don't know if they're still operating or not.
Yeah, that was a cool one too. All right, well, Rich, thanks a lot for sharing with us CQ tonight and all your knowledge on these other subjects. And you're welcome to stick around with us a while. You don't have to run off, but if it may be hot down there. I have no idea, but if you want to stay with us, you can. If you want to slip away at any time, you can. We're going to be tonight. I'm going to talk a little about the magnetic loops again. I built another one, and I got some pictures. I'm going to show a few things about it, and you're welcome to chime in at any time. Okay.
All righty, I appreciate it. I'll stick around for a little while.
All right, well, very good.
Unfortunately, magnetic loops is an area that I don't have any first-hand experience with, except for using one once, and I was amazed at how well it did.
Well,
I got to try building one sometime.
I have always wondered about them, how well they worked. My son has moved into an HOA area, and a magnetic loop may work very well for him. I don't know, and that's the reason I've just started recently looking. I always thought something that small can't work as good as something bigger outside, and I still believe that. And I've got some comparisons here where I did a loop inside the house and compared it to a 40-meter delta loop outside, at 50 feet in the air. There is a difference, believe me. But if you only have one or the other and you don't have the other one to compare it to, you might never know the difference. I was definitely hearing signals. And I have talked to people. If your alternative
is not being on the air, then that's definitely better than that.
And I have, on our 40-meter net, I have talked to people that were on magnetic loops, and we did a special on a show a couple weeks ago about it. And I was really impressed with the signal. And it started me thinking about at least experimenting with it and playing with them. And I started doing it, and I realized there's not much to them. There's only about 3 parts to a magnetic loop antenna: the loop, the capacitor, and a little smaller loop for the input on the loop. And they're very simple. And I was really surprised at the results I got. When you play with antennas, you throw these wires up and everything, and you can never get the SWR quite to go below 1.6 or 1.5. I built these magnetic loops up, and boy, I can turn that little capacitor there, and that meter, it goes 1 to 1, man. I mean, I was so impressed with it. But I've got some received video that I want to show tonight of one of them. So that's kind of what I want to talk about tonight. I thought we might do some shack pictures. We may not do the shack pictures tonight. I think hopefully Katie will be back next week, and Katie may do the shack pictures next week. What I want to do is I want to just show you the progression I've made from loop number 1, 2, and 3 the past 2 weeks here. So we'll be back in just a second, guys. Heard it, worked it, logged it. It's time to get the transceiver that's best suited for your lifestyle. ICOM offers a variety of high-performance and innovative products. Make the most out of contesting with one of these ICOMs today. The IC7610 is the SDR every ham wants. This high-performance SDR has the ability to pick out the faintest of signals even in the presence of stronger adjacent signals. The ICOM 7610 is a direct sampling software-defined radio that will change the world's definition of an SDR transceiver. It has 110 dB RMDR, independent dual receivers, and dual digit select, changing the way entry-level HF is designed. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. It has RF direct sampling, 15 discrete bandpass filters, a 4.3-inch color touchscreen real-time spectrum scope, and an SD memory card slot. The IC7851 allows you to keep your competitive contesting edge with faster processors, higher input gain, higher display resolution, and a cleaner signal. ICOM's IC7851 is a pinnacle of HF perfection. It has dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution spectrum waterfall, enhanced PC connectivity, and an SD memory card slot. Visit www.icomamerica.com/amateur for more information on ICOM radios.
LDG Electronics provides state-of-the-art antenna tuners for every amateur need. From QRP to QRO, fixed stations, portable and remote, an LDG tuner will match your radio to your antenna using our lightning-fast, proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
All right, so let's talk a little about what I did this week regarding loops. They've actually became kind of a very interesting thing for me to start looking into. You know, last week I mentioned to you that you know, I built the first loop just as kind of a beta test or a test. I just built it out of using some coax. And, you know, you see these for sale on the internet or at ham shows, where they actually use a piece of coax for the loop itself. And that's a 1/2 inch diameter piece of coax, and it's using just a shield. At the bottom of the picture, there's the capacitor, and at the very top of the picture, that's the coupling loop. So that's the one I built first. Now, it was a little flimsy, and it didn't hold its shape real well, even though it's like RG8 type material. It didn't hold its shape real good. And I found that when you would tune it, the thing was very touchy in tuning. All of them are. But if you make any movements or if the loop changes shape, it might change a little bit in its tuning. So I said, okay, and you know what? Hey, I got great results with this. Man, that capacitor there would cover 40 meters through 18 megahertz to 17 meters. So it really did well. It had a great dip. The SWR just went down to 1-to-1. I was really impressed with it. So I said, okay, let me build something a little sturdier. So we went with, you know, we went with a magnetic. I mean, we went with the magnetic loop built out of, this is 1/2 inch copper pipe. Now, a round one, and I've done a lot of studying the last couple weeks. I'm no expert on this stuff, but I read where a round one is a little bit more efficient. The hexagon one is a little less efficient, and then the square one is even your least or lesser efficient. But again, I use the same capacitor there. This one, if I go back to this one, this was a 6-foot diameter loop, 6-foot diameter. This one right here with the copper pipe was a 5-foot diameter, so it had roughly 20 feet of circumference there. Now the loops that you put on these things are supposed to be, everywhere I've read and everyone I've seen, the coupling loop is 1/5 the size of the big loop. So so you can also use that same type coupling loop on here, but as mentioned last week, I put a gamma match on here. You can see the gamma match at the top. The gamma match seemed to work pretty well on it. So I thought, okay, that's kind of big, and you know, let's see what else we can do. So I've got me some. I mentioned I had some hardline. I had the cable company guy give me some hardline. They rolled me off 100 feet of brand new aluminum hardline that goes on the poles, you know. This is about 3/4 inch in diameter, and it's pretty stiff. You know, it's when it stretches out between the poles, it kind of straightens out. But this is pretty stiff, and I found that it really holds its shape. So you can see there off the coil, it kind of coils up like that, and it's easy to expand it or contract it to the size you want. So what I did was I wanted to go, well, first let me show you something. There's the end of, that's what the end looks like. It's got a very large center conductor, which we don't use for the loop. That's about a number 8 size wire gauge there. It's got foam inside there, and then the shield is a solid aluminum jacket. You can see there, you can see kind of the diameter of it, close to 3/4 inch. I started thinking, you know, this is 75 ohm stuff. Hams use 50 ohm, but you know what? A lot of hams do use 75 ohm. And you can use, you know, hey, a dipole antenna is basically 70-something ohms, actually. So you could actually feed this to a dipole and get a pretty good match. But 75 ohm cable, I guess to a 50 ohm antenna would give you a 1.5 SWR, but it would work. And I started thinking, okay, so if I started thinking, all right, if I ever wanted to use that, how would I use that? I don't have any connectors for it. So I started thinking, hey man, I'll whittle down that center conductor like that, and I'll make that sucker fit a PL259. So look at there, I whittled it down, and I slid me a PL259 on there, and I guess you could probably take some type metal, wrap it around, you know, the hard line there, and the connector, maybe put a couple hose clamps or something on there. You could actually get you a connector on there. So, you know, hey, if you got a few thousand feet of 75 ohm, use it, man, use it. So anyway, back to our loop. I went with a 36-inch diameter, and that's kind of, a lot of the loops I was seeing was about that size, so I just wanted to play with that. So, you know, hey, you can saw it with a saw, or you can use a, you know, a tubing cutter or whatever you want to, and you know, cut it to length there. You can see the nice shiny aluminum jacket right there, which is real easy to connect to. Now, I needed some clamps, so you can buy these clamps right here at Lowe's for, you get 2 of them for about $3. Man, those things must be made out of gold or something, I don't know. Or it must be a lot of labor to make them. 2 for $3. So anyway, I had a roll of this stuff. This is the old plumber strap stuff, and I just made me a couple clamps like that. So I just made those clamps. I think those clamps there are just as good as the $3 ones, to tell you the truth. So anyway, and here's a shot here. I'm starting to lay it out again. I'm using a board where we're going to mount the capacitor. You know, I'm gonna have to connect the capacitor with the loop, so I needed something flexible there. So I just took the coax off an old piece of coax, kind of tinned the ends right there, and just kind of fastened it on like that. So that's kind of how I make the connection to the 3-foot loop. Just some stainless steel hose clamps, the copper there clamped very tightly to the aluminum. Now, dissimilar metals, yeah, but this is a beta test. This is me playing, seeing what it will do, right? So far it hadn't caught on fire or melted or anything like that, so it is working, but I didn't know of much better ways to mount the flexible shield there to the pipes. So I thought that worked out really well for us. So there it is again. You can see, just run the straps down to the capacitor, and that capacitor there is about a 40 to 320 picofarad, and that's just about the perfect size. It will tune that loop from 6 megs up to about, actually it will tune it through 15 meters. It'll tune it to about 22 megs. So the tuning range I got with that capacitor is about 6 megs to 22 megs. So it hits 40 meters and 20 meters, 17 meters, 20 and 15 meters. So I thought, okay, well, that's working out pretty good there for me. So then we start looking at it here, and I'm thinking, okay, I've got to have my coupling loop. I got to get a signal into it. Now that coupling loop there actually is the loop off the old loop. It's a little bit large. It's a little large for that 3-foot diameter loop, but it works, and it works pretty good. Let me see if I can show you something here. If I can remember where to go back. So here's the loop that I made. This is just the input loop. All we're doing is using the shield. You can see the shield is. Let's see if I can get closer to the camera. That's just the shield hooked to the both connectors on the SO239, the ground side and the center side. Now this was a little large, so I ended up using just a number 12 wire for a loop. I tried that and made it the right size, and it kind of worked fairly good. So I thought, okay, well, let's see if it makes any difference broadband or what. So I just built me a little loop out of some 1/4-inch pipe. And you can see, I just took an SO239, took a piece of copper, bent it, made a loop here, and of course, coax from your radio hooks here, and this loop just sits inside the other loop. And I found that moving it around a little bit actually, affects the coupling on how your signal will couple into the big loop. So I tried this loop, I tried a wire loop, I tried this loop. Let's go back where we were.
Tom, did you have to use, I'm blanking on it now. Did you use a regular soldering gun, or did you have to use a torch for that?
Well, I used a soldering gun on, well, of course, on the metal pipe. I did use a little butane torch, but on this, I didn't use a torch. I've got, and guys, been a ham for 55 years and even electronics more than that. So I've got an old Weller. I've got like a 275 watt Weller. Plus I've got a smaller Weller gun. I think it's 100 or 140 watts dual heat. But to do a SO239, you need some heat. But I was afraid that the torch would melt the inside of this. It would just damage this. So this actually a 275 watt Weller gun actually has enough heat to really solder that on right there. And the thing about these connectors, they've got a finish on them where solder does not want to stick to them very well. So I always take a little file and I'll file the connector and get that shiny slick surface off. And then I also will use some soldering paste, put a little soldering paste on there, and man, this thing it'll suck the solder up, and you can usually solder. So even the pipe was soldered on here with the Weller gun. I'll see if it'll focus. So you can see kind of how we built that. So here we are, it's out in the garage doing a little testing with it. We made the loop smaller to kind of match the size of the formula for the loop. So we built one out of a solid wire and put it on there. So we tried that. We tried the metal loop here. Let me see what other pictures I've got here. Let's see what this is. You don't want to look at that. It's sideways. Some of my pictures are sideways, and I couldn't fix them tonight in time. Maybe you can still make some sense out of them, though. Let's see. Here it is. Here it is in the ham shack. I brought it in the ham shack to actually try to connect it to a radio to see how it would work. You know, many people use these loops inside their home. So you can see it's holding its shape really well. It doesn't require any supports from side to side. And you can see the loop up at the top, I've kind of positioned it at different places, just trying to see where the best coupling spot is on it. Now, I wasn't real happy. It tunes great. It'll tune the SWR down to 1-to-1. It peaks when I tune it. I can hear the noise on the radio peak. I wasn't too impressed with hearing, listening to voices on sideband. Now, one thing I've got in here, and it may affect it, I've got a lot of fluorescent lights in the studio here, or in the shack. On one side, that light was just 5 feet away from the loop. That's over my radio operating position. If you go around on the other side and you look over the workbench, there's 2 more fluorescent lights. So there's a lot of fluorescent lights there. So that could be causing some of my issues there. I've got a couple little videos I'll play real quick if I can. Let's see. We won't go too long into them. Let's see. We'll try listening first. Here's the loop. It's very rigid. The aluminum hardline is very, very rigid. It holds its shape very well. So let's see what kind of tuning we can get with it. I'll manually tune this by hand, and let's see if we can watch the meter here. Very touchy again, very touchy. Let's see where that tuned at. So you can see it's tuning down really, really well. Right now I've got it at 14,300, 1.1 to 1. A minute ago I was seeing a 1.0 to 1. If we can, there we go, look at that, 48 ohms resistance, 1.0. It's a pretty good match there. I don't think we're going to get that on 40, but let's go to 40 and see. So we're going to go down to 40 meters, somewhere in that area would be good. I'm going to tune the tuning capacitor here, and we're going to see if we can find a dip. It's going to be very sharp. So let's see what we can get there. Don't quite have quite as good a match there. It's about a 2 to 1. About a 2 to 1, but it is tuning down there. Now, so you can see there that the 40 meter didn't tune down quite as low. It was about 1.4. But again, by moving that loop around, I was able to tune both 20 and 40 meters down to a 1-to-1 match. Someone asked about the formula for this. I think Russ asked about this. The formula for the loop is whatever you, and your big loop needs to be less than a quarter wave of the band you want to operate. So it needs to be smaller than a quarter wave to be considered a small magnetic loop. Now, you asked about what's the length of this. So the formula is whatever your circumference is of your circle. Let's say your circumference is I don't know, 10 feet. If your circumference is 10 feet, your loop is one-fifth of that. So 1/5 of 10 feet, the length of your loop would be 2 feet. 1/5 of the total circumference of the big one. And I have found that that's pretty accurate. I mean, the bigger loop didn't do any better or a lot worse. The other loop actually performed about as well. So, and it's amazing how you would think that just you hook your radio to that and that would get the SWR down to just a perfect match, but it's all because of the high Q of the antenna and the tuning of it.
Tom, is there a physical connection between the coupling loop and the main loop, or is that all inductance?
No, it's not. Let me see if I got a picture here. Well, there's the big loop with the capacitor at the bottom, and the little round coupling loop. I've just got it up here with some duct tape. You see, I got a piece of duct tape holding it up here. It's not supposed to touch, so it's not. It can't touch. Let's see. Go back to one of the older pictures. Well, you can see if you look closely there, you can see the loop again, the small loop. It's just positioned right below the big loop, maybe an inch. And I found by moving it up and down an inch one way or the other, it would greatly affect the SWR. So you got to kind of find the sweet spot right there to get your lowest SWR. So that's how you calculate the small loop. Let's see. I've got a couple of videos here. Let's see if we looked at this one here. This may be. That was the SWR test. Let me show you the receiving test. Now I brought it in the house, in the shack, and I hung it from the ceiling here with a bungee cord. It's one loop off the ground, and I hooked it to my 7610. And this video is going to show you some comparisons and what I noticed when it hooked to a real radio. So here we go. So that's a magnetic loop. 40 meter full delta loop. Magnetic loop. Outside delta loop. All right, so let's experiment with it inside the shack here. I've actually got it hanging here in the shack. It's about 3 feet off the ground, off the floor. I'm still playing around with the loop. Right now I just got the loop just kind of hooked on here right now. You heard the difference, S9 on the magnetic loop versus about 20 over with the 40 meter delta loop outside. If I move this outside, it might do a lot better. Also, but if I do that, I'm going to need to have a motor to have my motorized tuning. Okay, so one of the things that you heard me say in that last video is a motor. Most of these loops are tuned with a very slow RPM motor attached to the capacitor. Now, a couple things here, and again, I'm just doing this to experiment, you know. So I'm using a air variable capacitor. Now that air variable capacitor that you saw right here, this thing can handle it might be able to handle 50 watts, maybe. These loop antennas can generate up to 5,000 volts, and the current, the RF current through them can be anywhere from 25 to 50 amps. So that's a lot. So any contact point makes a resistor. The little rotary ball bearing on this thing makes a resistor. And when you run, 30 amps through that little ball point there, with maybe a little grease or something in there, you're going to get a big voltage drop. So the spacing on this capacitor will do maybe 40 watts, 50 watts. I was running about 8 watts just testing it, and I let my finger come off the knob there, and I think I touched the side of the capacitor, and I actually got zapped. Most of the builds that on the loops here are using vacuum variables. So the vacuum variable capacitors, you can order them mainly if you look on eBay. There's a good source for vacuum variable capacitors. And you probably need to get one from about 5 picofarad to about 500 is a common one. Now that thing would tune 80 meters down to 10 meters, 5 to 500. But they're expensive. They cost about $125, $130 for the capacitor. Now it's a vacuum variable, and you put a motor on it, a motor driven on it, and I made several antenna tuners and stuff where I actually motorized a coil or an air capacitor and remotely tuned an antenna tuner. But on this loop, they put a motor connected to the vacuum variable, and you can control it very easily. Now it takes about a 2 RPM to tune that. A lot of people are using 0.6 RPMs at 12 volts. The thing about a DC motor, it's reversible. So all you got to do is a little toggle switch, just reverse your current. You can run the capacitance up high. You can flip your polarity on your power supply, and it'll run the capacitor the other way. And another thing it does, it keeps you out of the loop. My experience with this loop was, as I was building and experimenting with it, I'm very close to it. My hand's on the bottom of it. My body's within about a foot or so from it. And that has some effect on it. Not a whole. With the round loop, it didn't have a lot, but it does have some effect on it. So by having the motor on there, you'll be able to tune it very sharply with a very slow RPM motor. Now I've got all my motors are on different things around here, so I've ordered me a 2 RPM motor to put on here. I'll mount it on this capacitor, not the variable, not the vacuum variable, but I'll put it on this regular air variable. But that'll allow me to put this antenna outside somewhere, a little bit away from the house, maybe hanging over a tree limb or something out there. And then I can tune it by the little motor. And that becomes really helpful because the thing has a bandwidth of about 40 kilohertz. So if you wanted to tune down a band, it would be out of tune. I'd have to go out there and turn the knob again to set the antenna. It's very sharp, but I found that you could actually, without any special test equipment, you could actually tune this thing to an operational point. For instance, you could tune it. You could watch either your band scope on your radio, and you could watch the noise level, and you could watch, when you tune it, you could watch a big hump come across that noise level. The noise level would come up. If you don't have a scope, you can watch your S meter. Your S meter would come up when it's tuned about the right place, and then as you keep tuning, your S meter would go back down. So I would tune till the S meter is peaked out, and then kind of standard procedure with a loop would be to always check the SWR first, because even though I peaked it on receive, When I did put the radio in transmit and did a test transmission, I was like at 2-to-1. And it took just barely touching that capacitor to make that 2-to-1 come down to 1-to-1. So you could actually use the meter on your radio to actually tune the antenna to the resonant frequency. Now, the antenna is also a little directional. Some people are starting to put rotors on these, and again, they don't have to be mounted very high. They're saying maybe one loop diameter off the ground. But the loop is a little bit directional. I tried turning it some, but I was unable to really peak much of a signal. I thought I had a video here of receiving on the air. Maybe this is it. Let's see. I checked it a minute ago. It only. Well, we're having some difficulties there, but I was able to tune it, and I was able to hear people with it. I didn't try to transmit with it here. But where I put it on my antenna switch, so I had my outside delta loop up very high out there. In one position, I had the magnetic antenna on a different position. So it was very easy for me to switch between the outside antenna and the mag loop. And I noticed at times the outside antenna, a person would be 20/9. I'd flip it to the mag loop and it'd be only a S9, you know, that big a difference. I found sometimes though the outside antenna would be close to an S9 and the mag loop antenna would still be close to S9. So I was having trouble understanding the difference between the two. So anyway, that's just some of the things that I have been playing with and experimenting with this week to just to see how how mag loop works, and I'm kind of impressed with it. So what do you think, Rich? We all need to get mag loops now.
Well, it's certainly something to put on my agenda here to try sometime soon. I'm not sure I've got the right soldering equipment for it, since most of what I've got now is small irons for kit building, but I've got friends, so that always helps.
Oh yeah, you can borrow a soldering iron, and it's not that much soldering to do on one. Actually, the only thing I soldered on there was the little loop to an SO239. So that was it, man. It's so simple. It's so simple that there's only like 3 parts in this thing. There's the round loop, which is nothing. There's the capacitor on one side, and there's the little round loop at the top. That is it. Now, of course, if you want a professionally built, $700 magnetic loop, they're gonna, it's gonna look a lot better than this one, and it's gonna probably, it'll have the tuning built in, the voltage tuning, and it'll probably be in a nice package, and you don't have to get out in the shop and work on it. But this was just kind of fun. I've experimented and built stuff all my life, and
I got to come up with something that I can fold up and put into the saddlebag on my bike to take out remote QRP operating.
Well, this one right here, people sell this loop, and it's made out of coax. The loop is coax. You can just fold that thing right up, throw it in your backpack, and I guess just a couple of terminal screws, just tighten the capacitor on there. Once you get it laid out and working, then I think you can just disassemble it, throw it in a backpack, and go. You could probably set the thing up in 4 minutes. It's not much to it,
Definitely worth thinking about.
So, hey, another thing about magnetic loop, it is directional. It's directional off the ends. You'd think a loop like my 40-meter delta loop, it's directional off the sides, broadside to it. But a magnetic loop uses magnetic waves, and the directivity on a mag loop is, for instance, if this is the loop, if that's your loop right there, your magnetic waves and direction is going to be this way. You know, it's not going to be broadside to it like this. So it'll be, you know, you can rotate your loop there, but directivity-wise, it's going to be off the sides. So anyway, that's kind of, I don't know what I'm going to do. I guess I'll wait now till my motor comes in before I do any more with it there. I'm going to open the phone lines in just a minute. But hey guys, I got on FT8 tonight. First time I've got on FT8 ever. And it only took me about 1 day to figure out how to make it work. You know, I went to, I'm running a wsjt-x, and it has all the digital programs in it, like FT8, FT4, JT65, and so forth. And I hooked it up to my 7300. The hookup was pretty easy, and it would actually control the radio. When I'd go to like FT8 on 40 meters, it would automatically put the radio on 7073, I think. I mean, it would actually switch the radio, so that worked pretty good. The problem was, and finally I started receiving some signals, but I couldn't talk to anybody, and I couldn't figure it out. I went to YouTube, and there's 4 or 5 guys out there that tell you how to set up a 7300 to work with FT8. Every one of them tell you different, and I tried every one of them, and none of them worked. And I kept playing around with little settings in the setup, and I finally found one that worked. So I wrote it down. So now there's a 6th guy out there that knows how to set up the 7300 to make it work with FT8. So anyway, so I started receiving fine. That's great, and but I couldn't make it transmit. That was some of the little settings. I finally got it transmitting, and people still weren't answering me. And so I'm starting to kind of think things through. They're not answering me. And, you know, I finally realized, you know, I thought FT8 is going to be this miracle digital mode. If you hear somebody, you call them, you automatically get this connection and, you know, weak signal and all that, it's going to work. Well, it doesn't. So I finally realized that my experience is we probably got some great FT8 users on here that just know everything. But I discovered that everybody's not going to answer you, just like you're not going to answer you on sideband. I started thinking, you know, if somebody calls CQ and on sideband and you try to answer him, sometimes he doesn't hear you, or sometimes he answers somebody else. And that's exactly what's going on with the FT8. You have to just keep calling, and eventually he may answer you. Another thing, if the signals are real weak, it makes it more difficult to make a connection. And the program gives you the signal strength of the person. And I did notice on the stronger signals, I had much better chances of making a contact with them. I got a little 30-second video here. It's a contact I made on FT8. This is my very first FT8 contact. I've been a ham 55 years, touched on digital just a few times over 50 years. I haven't been on in years, never been on FT8. And hey, the interesting thing about FT8 is you don't even have to type anything. You just click on a guy's name, it calls him, he answers back, it sends him his signal report, he sends you his signal report. You tell him thank you, goodbye. He says thank you, goodbye. And then that's the contact. You didn't have to do a thing. Now, if I could just figure out how to keep that sequence going, I could leave home and work 100 countries while I'm gone, man. You know, let me show you a little quick video here of my experience today with FT8. All right, we've got FT8 installed here on our PC. We've got it running on the
Tom, I'm going to jump out.
LC7300.
Do some stuff. So good
Using
talking.
a
You
40
enjoyed
meter,
it,
20 meter
and,
dipole. Let's see
see
if
you
we
next
make a
month.
contact here. Okay, thanks. We'll see you. There's an IK4 in Italy. Let's see if we can get him to answer us. So we're calling right now. Each segment is 15 seconds long, you see right here. So we called him. Yeah, let's see if he answered. Nope, he didn't answer us. We're calling again. Looks like we got an answer from Italy. We're now sending back his signal report, which is a +3. We should get a signal report back from him. And we got a signal report back from him, or let's see, well, he said Roger, Roger, 73, and I'm saying 73. He gave me a signal report of a -16, gave him a signal report of a +3, it looks like. Okay, well, we made a contact here to Italy, so that's what it looks like. To log it, we'll just go up here and we'll hit the log button. So it's logged now. Down at the bottom you can see some of the waterfall there of all the contacts going on right now. Okay, so that was my experience today with FT8. So I've got it working, and yeah, there's some comments in the chat room. Your computer clock has to be within about a half a second at least to really function properly. There's little apps that you can download for your computer that will synchronize your computer clock to the exact time. So that was pretty easy to do. There's other things I don't understand. Some people start on the even minute. Some people start on the odd minute. I haven't got that figured out yet, but I'm just making contacts. You know, this is you know, one of those low signal things. People are actually using FT8 and making contacts, you know, 2,000 miles away using a light bulb in the window for the antenna. So it's very interesting there. My reason for wanting to set up the digital here is, again, soon on the show, maybe this winter, I want to play with some moon bounce stuff. Now, I don't have a high power station here. I'm not going to be able to make a sideband contact through the moon. But what we can do is use JT65A, which is made very specifically for moon bounce, moon communications. And he also has, Joe Taylor has also added a echo window that, and I don't know much about it, but there's an echo window where you can open up and you can see your signal. So you can actually send a signal to the moon and you can see the return signal on your PC. So I know it's not that easy, but I think with 100 watts and a 13 element Yagi, it's possible to do that and see your signal come back. With 100 watts and a 13 element Yagi, it's also possible to make a contact with someone else in a different part of the country or world, as long as you're running, you know, a digital mode. And also, you know, I would be a small gun, and if I could connect with a big gun, somebody's got a lot of antenna and a lot of power on that side, it makes a big difference on my side. So it's even possible to make some connection, you know, some contacts there. I don't particularly want to make a lot of contacts on moon bounce EME, but I did want to just send a signal up and see it come back with this. But I've got to learn how to work all this, the echo back and all that stuff. I got the phone lines open. I'm gonna put the number up there, and we'll just open the phone lines just for a few minutes. Let me see, phone lines right there. There we go. So we'll put the phone lines up, and we have our music. So if someone wants to call in tonight and say hello or talk about anything, we can do that. 712-775-7270, and you have to do the code. I'm going to put the loops back on my workbench. Phone lines are open if somebody wants to call. Let's see. Oh, let's see. Well, we've been on about, I think we got a phone. So the music stopped, so that means somebody's on the phone. Who's on the phone?
Well, Tom, are you getting me all right? Russ.
Hey, Russ, how you doing?
Oh, real good.
Wait a minute, Russ. Hey, Russ, I need to check the audio. Is the audio coming back to you okay on the phone?
Yes, well, yes, it is.
I mean, sometimes, yeah, sometimes Microsoft pumps it up so loud that it's real distorted. Let me just check it. There's somebody else on there joining us too.
You're just a tad loud, but it's...
Yeah, let me check it here. I'm going to open the sound settings. Let's see. I'm going to select sounds. It'll just take me a second to check it here. Well, I'll get there in a minute.
You're sounding good here on the phone.
Yeah. Let's see. I got to select sounds. And then recording. Well, if it's sounding okay, I'm not going to worry about it.
No, that sounds good.
Is it okay? Where's
Teresa, your producer?
Yeah. Who is that on there? Who's the other person?
This is Todd, K0IZZ.
K0IZZ, Todd?
Yes.
Hey, how you doing, man?
Oh, good.
Speak a little louder. Get a little closer to the phone. I can't turn.
Hey, Tom, how's it going?
Doing pretty good. I can't turn you up.
Okay, we'll try. How about that?
That's better. I can hear you.
Oh, yeah, that's fine, Tom. We're sitting here watching you do the antennas. We're sitting here watching you do the antennas and everything, and we're sitting here winding up a 9-to-1 on.
Yeah.
And trying to get her done.
All right, man. Well, have fun with that. And you're out. Where are you? Omaha or somewhere?
Oh yeah, and the guys just asked me too in the background. We're all the way up here in St. Paul, Minneapolis, Minnesota.
Oh, okay. All right, I got you. You're a little bit lower than Russ as far as audio. It's just different phones.
Yeah. All right, Tom.
All right, man. Hey, I'm glad you checked in the net tonight. Appreciate it.
Yeah, no problem, Tom. It was good to hear you finally. We had to pump it up to 100 watts.
Yeah, but I got you. I heard you. We'll see you next Tuesday, man. And then tell us how
All
that
right, thank you, guys.
tell us how that new antenna is going to work for you.
All right, we will. We'll keep in touch.
All right,
Thank you.
we'll see you. Russ, you still there?
Yeah, you bet.
Yeah. You still there, Russ?
It was kind of funny you were on FT8 today, because I was, and I never do FT8 anymore. I did that quite a few years ago and got kind of burned out on it or whatever. But I was on today simply because I finally got an antenna up in my new apartment, and unfortunately it's inside. And I thought, well, let's go to FT8 and just see what kind of signal I got, so I could get to PSK reporter, and then I can see who's picked me up.
Yep. Yeah.
And so I made a contact with the first contact I made was in North Dakota. However, he gave me a signal report of a -20, which is pretty bad.
Yeah.
I mean, he got me fine.
Yeah.
I gave him a -16. Okay, this inside thing's not going to work well, but we'll see. So anyway, I found out I'm getting all over the United States, and so I'm still thinking of something different. I had a wooden fire escape in my old place that I put up kind of a hidden antenna on, and it worked pretty good. Well, this one doesn't have the wooden fire escape, and there's really no way of doing something. So I was thinking of magnetic loop, if not a balcony type ham stick. That's why I was asking about the length of the loop. I'd like to do 75 meters up to about 20 meters.
Yeah.
Does the diameter of the loop make a difference on the bands?
Yeah, and let me tell you again, I'm sure we got some loop experts on here tonight. I'll tell you what I have read just over the past couple of weeks in studying this. First of all, to be a small magnetic loop, there's a definition that it needs to be 1/4 wavelength or less in size. Or it needs to be less than 1/4 wavelength. That's kind of the general definition.
Okay.
So
you go to your lowest band and go less than than 1/4 of a wavelength. I mean,
so like this loop I built here. This loop is a 3 foot in diameter. So 3 foot in diameter. The circumference of that is 3 times pi, 3 times 3.14, which is about 9.5 feet. So the circumference of a 3 foot antenna circumference is about 10, close to just a little under 10 foot. That means your coupling loop is going to be 2 foot in length, and you just bend it in a circle. You bend both up in a circle, so you got a 2 foot circumference circle for your input. You got a 10 foot circumference for your main loop.
That's what you were talking about, the 1/5 in size. It's not so much the length, it's the size of the loop then. Your smaller loop wants to be 1/5 the size of the outer.
Yeah, no matter what band you're on, my understanding is, and I've tried different things here, and I've looked at hundreds and hundreds of loops and building loops, the input loop is 1/5 the circumference of the big loop. So if your big loop is 10 feet, then your small loop is going to be 2 feet. That's circumference now. That's circumference.
What I was asking before was how long. I was wondering how long would you start with then for the length, like for 75 meters, and then make it into the loop. You've got, let's say, 12 foot of wire, and you put that into a loop. That's going to give you I don't know what.
Well, let's look at. Okay, let's think of something. I mean, in this 3 foot loop, people are using this 3 foot loop on 80 meters, but it becomes much less efficient. So if you had a 5 to 500 picofarad vacuum capacitor, variable capacitor on there, this thing would probably tune 75 meters fine. It would probably tune all the way through 10 meters fine. But I guess the larger the loop is compared to the real wavelength, you're going to get higher efficiency. This loop right here, the 3-foot loop, is going to have much more efficiency on 20 meters, and it's going to have less efficiency on 40 meters. And if I put a cap on there that would hit 80 meters, it's going to be even less efficient. And the efficiency may be 10% efficient on 80 meters. And 10% efficient is pretty bad, but if you're not comparing that with somebody else's antenna and you just have it hooked up and you're hearing somebody, you don't know that 10% is really bad. So you were asking how big for So let's build an 80-meter magnetic loop. So the definition would be it has to be under 1/4 wavelength. So a 1/4 wavelength on 80 meters is about 66 feet. So 66 feet in 66 feet in circumference.
So you go with 50 foot then?
So if you had a diameter, if you use pi, if you had a diameter of 20 feet times 3.14, that's about 60 something feet. So to get right under 66 feet, you'd have to make a diameter of almost 20 feet.
Okay, that's what
20 feet, you know. And then again, your 66 foot, 1/5 of that, or 0.20 of that, would be 12. Would be about 13 feet. So your small loop would be about 13 feet. But you know that's impractical to build something that big to set in your window, or you know, a glass door or something. You can't have something 20 feet in diameter. You know, that won't work. So that's where they're using magnetic loops.
I've got capacitors here from, or as you know, broadcast engineer. I've got capacitors from 5,000 watt AM transmitters and such. I got big.
Yeah.
But they would work fine. And I'm just thinking, okay, so basically I could build one for 40, and it probably will work on 75.
Possibly, yeah. It's just going to take. It'll just take more capacitance. So if you got a big capacitor, you know, and I mean you can always bridge a capacitor across it, or even cut a piece of coax. You know, coax has so many picofarad per feet. You can actually parallel a straight piece of coax across there and trim that coax to a certain capacitance. But I wouldn't go that route. I would go with a capacitor. And again, if you got some wide space, you know, 1/4 inch wide spacing air variables, I'd use them.
I've got those.
To get to, tell you what, and also just do a search, do a Google search, and here's a formula. There's many loop calculators out there. And on the calculator, you put in your diameter, and you put in the frequency, and it'll tell you what size capacitor you need for that frequency, and it'll tell you, you know, the circumference. It'll tell you all that stuff. So it's really cool. And whether I use the coax loop or the 20-foot circumference copper loop, or this round loop, the same capacitor, I used it on all three. This is about a 30 to like 350 picofarad, and it tuned just about identical on all three of them. It would tune me from, you know, about 15 meters up to just above 40 meters. It actually would go to about 6.5 megahertz. So it was interesting. And you know, you might could just build one for a particular band or one or two bands. I think if you try to stretch it across all bands, you know, it'd probably work. But
well, I do 40 a lot. I do 75 a lot. 75 is going to be a little big, but if I could build one and fit it in here for 40, so with the capacitor, I probably should be able to do 75 okay. because I'm not going to do that with straight wire.
Yeah.
Not in this place. So, all right. Well, that helps. That gives me some indication. I've looked them up before, and I can't tell how big a loop you really need to have, either the big one or the small one. So
Well, it needs to be smaller. A
1/5.
magnetic loop needs to be smaller than a quarter wavelength. But many of them are much, much, much smaller than that, because even a quarter wavelength on 40 meters, you'd have a loop, well, I don't know, you might have a loop 10 or 15 feet in diameter, but the people are having great success with these small 3-foot loops. And that's the reason I wanted to go with the 3-foot loop. There's no real set measurement for our loop. I could have made this a 3-foot loop, 3.5-foot loop, 4 foot, 4.5, 2-foot loop, 2-foot diameter. I could have made it any of those things, and it still tunes the same.
So there's no resonance in there, is what you're saying.
Yeah, it still goes to resonance. It still goes to resonance. Yeah.
Okay. That's what I needed to know. Well, I'm gonna try one here. Maybe by next a week from now, you might be hearing me on 40 meters, and I'll go, hey, guess what? It's got the magnetic.
Yeah.
loop
Hey,
working.
I'd like to hear your experience, man, and what you came up with. Again, I thought there was some magic to it, and of course, I'm sure there's some magic to it. The construction and professionally constructing it and connections and stuff. Just like Martin tells me, MFJ sells one. It's pretty expensive, and it's aluminum. It's just aluminum. It's about I don't know. It's somewhere around 3 foot in diameter.
It's a gorgeous antenna.
Yeah, but
it's
everything is all welded, because this thing operates in the milliohms, not 50 ohms, but you're down in the milliohms. And one of the things on the air variable capacitors, if you can find a butterfly capacitor, it's got 2 sides and then the plate that goes between them. If you can find one of those, that will work better for you. Or if you can find,
that's what I've got.
Yeah. Or if you can find like the old broadcast radios where they had 2 different sets of stators and rotors in there, 2 different sets. What you do is you connect to each of those, the 2, and you're not going through that pivot point of that knob. The current's not going through the pivot point. The only thing is you're going into the 2 different sections of the stator, and then those rotor blades are just going in and out. Nothing is actually physically hooked to the rotor blades, so you're bypassing that.
Well, that's what I've got with these.
Yeah, you're bypassing the milliohms there, and MFJ, everything is welded. I've got stainless steel hose clamps. I've got screws and bolts, and a capacitor. I don't have the butterfly capacitor in there. MFJ has welded everything, so there's no loss. And again, guys, I was very surprised to see that very easily the voltages can reach 4,000 volts on that loop. 4,000 volts, and currents of about 25, 27 amps. And even I've seen some articles where it even goes up to 50 amps at 4,000, 5,000 volts. So
that's totally unbelievable.
Yeah.
But Tom, thanks. I really appreciate your show tonight, and thanks for your help. Now, we're going to try to build one.
okay.
When we get to you here in another week or two, I'm going to definitely let you know that, hey, you're hearing me on a magnetic loop. Thank you.
Well, I'll tell you something. I guarantee you it's simple. And if you just got a few basic parts and knock it together, you'll be surprised how it tunes and so forth. You're going to want to try to add a motor and either a turn reduction. Someone mentioned, why don't you use a turn, like a 5-to-1 turn reduction? Some people do. I mean, you could use a turn reduction, but then you still have to match the motor up to get your tuning speed.
I got some stepper motors. I'm going to
Yeah,
try them because they just go a little dab at a time, you know.
Yeah, I'm not smart enough. I'm not smart enough to use a stepper motor or how to, figure. I need to get Glenn Popel on here and get a little Arduino thing going with some stepper motors and add it to this loop here and make that a project. Maybe we can do that one night.
I got a Raspberry Pi that powers the stepper motors. That's not a problem.
But you're going to find on that capacitor, if you turn it by hand, normal speed, you will go across the resonant point and you will not see it. You're going to have to tune very, very slow and watch. If you've got an antenna analyzer, that's the best thing just to start with, to play with.
Yeah.
And you're going to watch those needles. And then you're going to watch those needles go bam like that, man. And they come right back up. They're fast.
That MFJ antenna analyzer.
That's why, and that's why you need like a 2 revolution per minute motor, and maybe even smaller, where you can just barely move that capacitor. You want to move it, a hundredth of a millimeter, man.
I'll keep in touch with you and let you know, and maybe we'll make a contact. Once in a while we have made a contact before.
Yeah, okay.
Maybe now we'll do it on an antenna that you helped me with. So thanks.
Well, very good. Thanks.
Tonight, Tom. Really good.
Thanks, Russ. We'll see you, Russ. 73. All right. Hey, I see Mark KE8HIW in the chat room. He's probably not paying attention. Mark, are you on the air yet? Mark got his license over a year ago at Hamvention, and I took him up a HF radio that he bought from a friend, and I built him some antennas and took it up there. I even gave him some antennas. All he had to do was throw them in a tree, and Mark, as of this Hamfest 1 year later, he had not got an antenna up yet. What do you think about that? Mark, talk to us, Mark. Have you made any contacts yet? When I look at his call on the chat room, it looks like KE8HIVV, but that's not right. KE8HIW. The antenna's up. All right, man. We need to do a whole show. Now, Mark, did you make any contacts? Now, don't be depressed if you didn't make a contact the first time you got on, or you didn't know what you're doing. Hey, when I was 16 years old, 55 years ago, I made my first contact. I didn't know what the guy was saying on CW, and I think I cried. So, I don't know, Mark, have you made any contacts? Well, all right, guys. Hey, the phone line's still open, 712-775-7270. Put the code in here, hit the pound sign, and you can connect to the show. If you'll call in, the music will stop. Not had a chance to set more of it up. Man, oh man. All right, I tell you what, Mark, when I come to Dayton next year, that'll be 2 years. If you hadn't got it on by then, I'm going to get a group together and we're going to come over to your house and we're going to get it on the air for you. Here's a ham. It's got him an HF radio, antennas, and he still hadn't got on the air yet. No, I don't know if I can change the tune or not. You're going to have to listen to that until you call in. Guys, I want you to look at see my arm right here. Look at here, guys. Look at that. You probably can't see it, man. I went to a doctor today, to get the yearly physical, and he's got some new nurses in there. And this one nurse, boy, she kept stabbing me right there, and she never could get anything out, And I said, well, try it again or stick it there, and she never really got anything out. So she went and got another girl to come suck the blood out there, and man, she just came right in and hit it and got all the blood, and it took like just a few minutes, man. Oh, man. They usually don't do that to me. Yeah, okay. Yep, somebody's on the phone. The music quit. This is the day the music died. Who's on the phone?
Richard, KB3ZVH in Erie, Pennsylvania.
GDH in Pennsylvania. Was it K what?
KB3ZVH.
Okay.
KB3ZVH.
All right, let me turn you up a little bit here. I need to get a little bit more gain on you guys. I got KB3GDH.
KB3ZVH. ZVH.
Oh, it's ZDH. Okay, I got you there, man. Okay. How you doing today, man?
Doing pretty good. Really good show tonight. Hey, want to get your opinion. What do you think of the Alinco DX-SR8 as a radio or a transceiver, for that matter?
I don't know much anything about that. Is that an HF rig or a VHF rig? HF. Yeah, I don't know anything about that radio. I don't own any Alincos or know anybody that did. I know back like in the 70s, Alinco made a 2-meter rig that we bought several of, and they had some pin diodes in there, and those pin diodes were always going bad. But that's not to say anything bad about this one. I'm sure they've got their act together since the 1970s, and it's probably a pretty decent radio. Is it like a QRP radio?
No, it's actually 100 watts, full 100 watts.
Wow.
In fact, I've got some pretty good signal reports from you on the net.
Oh, so you're running it, huh?
Yeah, I'm running 100 watts.
Okay. All right. Well, cool. I don't know. There may be somebody in the chat room that is familiar with that. Have you gone to EHAM and looked it up and see if there's any discussions on it?
Oh yeah. There's good, some bad. Some right down the middle.
Yeah. Well, that's the way it is, man. You got to take the bad with the good, don't you?
Yeah, most definitely.
Somebody's not going to like anything or everything. Well, great. I'm glad it's working well for you.
Okay. Well, hey, I'll let you go so you can get another call.
Okay. Hey, stick around if you want to. We can take up to 1,000 simultaneous calls, so you don't have to get off if you don't want to.
Oh, I'll get off so I can hear.
Okay.
The other calls.
All right. Very good. All right.
Okay. Catch you later.
All right. Thanks for calling. Anybody else on the phone? Oh, no, guess not. Oh. I think I could play that. That almost put you to sleep, won't it? All right. Well, guys, let's see what time it is. It's about time to end the show, I guess. So we're going to go ahead and call it a night. We'll cancel the phone call. All right. We will take the phone number off the screen. Well, I hope you guys had a good time tonight. We're trying to get things back together. I've talked to Katie this week, and Katie sure wants to be back on here. There's some things that have kept her from being on here, and but she's going to be back on here soon. If somebody from Michigan is calling me, let me know if that's you, because I'm not gonna answer it. Yep, I'm not gonna answer it. If I don't know you, I won't answer it. Hey guys, there's a thing out there. We got our phones here at home. We've got what we call Nomo Robo. if you do a Google check, no more robo, and you can list your number in no more robo, and it knows pretty much, it knows all the spam calls that are out there. I guess they're registered somehow, and it will block those calls from coming to your house. Your phone will ring one time, and then that's it. It doesn't ring anymore. So if we hear a one ringer, we know that was a robo call. Bill collector. Yeah, it might have been a bill collector. I don't know, man. Don't know. So anyway, Katie, hopefully Katie be back here next week. I think she's hoping to be back. She thought she'd be back tonight, but didn't make it. She's been traveling some. I know she's got some other travel coming up with some Hamfest she's got to go to. And Dave's going to be out a while, but hey, we've got plenty of people to come on here and help us have a good time. Martin Jew, Riley Hollingsworth. Dave's going to be out a while with his singing. I don't know if Dave sings or not. We'll have to get him to sing one night on the show here. All right, I'm going to say good night to everybody. Thanks for tuning in tonight. Remember, join our Facebook group. It's called W5KUB. 8,000 hams in that group. Great ham radio group. Join it there. We will see you guys later.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.